Let's say I want to find the refractive index of water using the critical angle. What I do is, you see this one, if you follow the rules of total internal reflection, the ray must go from more optically dense material to less optically dense material. For example, water to air. Okay, in this case you look at the arrow going like this and then coming out like that. But for me to find out the angle of critical angles to be used for finding the refractive index of water, I'm not interested to get air, because in this case if you follow the convention of more dense to less dense, you're actually finding the refractive index of the less dense material. You're finding the refractive index of air, so you have sine C over sine 90. So the optical refractive index of air is actually sine C over 1, which is just sine C. Okay, but I'm more interested in finding the refractive index of water. So what I do is I use another color to represent this direction, double arrow red. So this double arrow red tells me that I'm supposed to go from less dense to more dense material. So I'm actually finding the refractive index of more dense material, which is the water. So because of this, I can take sine I over sine R, which is sine 90 over sine C. So in the future, you just have to use this formula, n equals to 1 over sine C, because sine 90 is 1. So this one is to find the refractive index. We find the refractive index of the more optically dense material. We are getting the refractive index of the more optically dense material. Okay? So this is a formula for refractive index.